The electric vehicle revolution is, at its core, a revolution in energy storage. While electric motors have existed for over a century, it's the battery that has finally unlocked the potential for mass-market EVs. The ability to store and deliver energy efficiently is what makes the modern electric car possible, and it's this technology that's driving the industry forward at breakneck speed. The battery is the most important, expensive, and hotly debated component of any EV. It's not just a power source, it's the heart and soul of the vehicle, determining how far you can drive, how much you'll pay, and how long your car will last. It dictates range, cost, and lifespan, but also impacts charging speed, safety, and even the car's environmental footprint. Every advance in battery technology ripples through the entire EV ecosystem. Automakers know that whoever wins the battery war will win the EV race. The stakes are enormous, with global leadership in the auto industry hanging in the balance. This is why billions are being poured into battery R&D, as companies and governments alike search for the next breakthrough. The race is on to develop batteries that are cheaper, safer, and more powerful than ever before. The market is split. High-performance nickel-cobalt batteries offer impressive range and power, but they're costly and depend on volatile, sometimes ethically questionable, global supply chains. LFP batteries, on the other hand, are cheaper and safer, with a longer cycle life, but they're heavier and less energy-dense, which means less range for the same weight. Consumers and car makers are forced to choose between affordability and performance, weighing the pros and cons of each battery type. It's a tough decision that shapes the future of every new EV model. The dream? A battery that delivers both high performance and low cost, with safety and sustainability built in. A true game-changer for the industry. For GM and Ford, this is urgent. They're not just competing with each other, but with Tesla, the EV pioneer that has set the standard for battery innovation and efficiency. Tesla has led in battery tech for years, pushing the boundaries with every new model. For Detroit's giants, catching up will require a leap, not just an incremental improvement. Enter lithium manganese rich, or LMR, a new battery chemistry that could finally break the cost-range compromise, offering the best of both worlds. Developed quietly in labs over the past decade, LMR is now bursting onto the main stage in 2025, promising to transform the EV landscape and redefine what's possible for electric mobility. It's Detroit's boldest move yet, aiming to reshape the American auto industry, secure a leadership role in the global EV market, and put U.S. innovation firmly back in the driver's seat for the next era of transportation. LMR, or lithium manganese rich, is an innovative new battery cathode chemistry that's generating a lot of buzz in the electric vehicle world. Major automakers like GM and Ford are especially excited about its potential to transform the EV market. The secret? LMR uses a high proportion of manganese, a metal that's not only cheap and abundant but also widely available from stable global sources. This allows manufacturers to dramatically reduce their reliance on expensive, supply-constrained, and often ethically problematic metals like cobalt and nickel. Right now, the battery market is dominated by two main options, each with its own trade-offs. High nickel batteries offer impressive range and performance, but they come with a hefty price tag and supply chain headaches. On the other hand, LFP batteries are much more affordable and stable, but they sacrifice energy density, which means less range per charge. LMR aims to be the Goldilocks solution, offering high energy density and long range, but at a cost that's much closer to LFP batteries, making it just right for mass-market EVs. GM's LMR cathode, for example, is made up of about 65% manganese and 35% nickel, with zero cobalt, a huge shift from today's high-nickel, cobalt-heavy batteries. Manganese is not only abundant and easy to source, but it also avoids the ethical and environmental issues tied to cobalt mining, especially in places like the Congo. By swapping out expensive and controversial metals for manganese, manufacturers can slash costs significantly without sacrificing the performance that drivers expect. This isn't just a minor tweak to existing batteries, it's a fundamental rethink of battery chemistry that could reshape the future of electric vehicles. LMR technology proves you can achieve premium range and power using more sustainable, affordable materials, making EVs more accessible to everyone. With LMR, the dream of electric vehicles that finally break the trade-off between price and range is closer than ever, and it could change how we drive for good. In 2025, LMR technology moved from lab to mainstream as GM and Ford made it central to their EV strategies. Ford teased major investments while GM publicly declared LMR a leap forward. GM began developing LMR with LG Energy Solution back in 2015 and after years of research is ready to scale up. GM plans pre-production of LMR cells in late 2027, with full-scale production in 2028 for key models like the Silverado EV. Ford is on a parallel track, investing heavily in its own LMR R&D. This coordinated push signals Detroit is no longer just catching up, they're aiming to leapfrog the competition. With LMR, GM and Ford are betting big on redefining the EV game. LMR technology is emerging as a game-changer for electric vehicles, directly addressing three of the biggest challenges facing the industry today: range, cost, and material access. These are the pain points that have held back wider EV adoption, and LMR offers a promising path forward. According to GM, LMR cells deliver 33% higher energy density than the best lithium iron phosphate, or LFP, cells on the market. This leap in energy density means that even large vehicles like SUVs and pickups can achieve over 400 miles of range on a single charge, making EVs more practical for long trips and daily use alike. But perhaps the most significant advantage is cost. LMR technology could slash battery pack costs by as much as $6,000 compared to high-nickel batteries, a savings that can be passed on to consumers and help make EVs more accessible to everyone. These savings are possible thanks to the use of more affordable materials and a smarter, more efficient battery pack design. By using fewer, larger prismatic cells, manufacturers can reduce the number of parts, streamline assembly, and cut down on manufacturing complexity and costs. For instance, the Silverado EV's battery pack drops from 24 separate modules to just 6 with LMR technology. This is a dramatic simplification that has ripple effects throughout the manufacturing process. Fewer modules mean faster assembly times, less weight to carry around, and ultimately, more affordable electric vehicles for consumers. It also opens the door for automakers to scale up production more efficiently. Another key benefit is material access. LMR batteries rely on manganese, a metal that is both abundant and can be sourced right here in North America. This is a major shift from the current reliance on scarce or geopolitically sensitive materials. By tapping into local resources, automakers can reduce their exposure to global supply chain disruptions and price volatility. This shift also lessens dependence on China, which currently dominates the battery materials market, and helps create a more secure, predictable, and resilient supply chain for North American manufacturers. By building their battery strategies around manganese, companies like GM and Ford can better insulate themselves from geopolitical risks and ensure a steady supply of critical materials. In short, LMR technology represents a holistic solution for the EV industry, delivering better range, lower costs, and a more robust, future-proof supply chain that benefits both automakers and drivers. Tesla has dominated EVs with its battery tech, using high nickel for range and LFP for affordability. LMR from GM and Ford is the first real challenge to Tesla's strategy, breaking the performance-cost trade-off. With LMR, Detroit can offer long-range trucks and SUVs at prices rivaling Tesla's standard models. If a Silverado EV or F-150 Lightning delivers 400-plus miles of range for less, it could shift the market. Tesla has acknowledged manganese's potential, but hasn't announced LMR-style batteries. While Tesla talks, GM and Ford are ready to launch. If LMR delivers, Tesla may be forced to play catch-up for the first time. Detroit could finally set the agenda in the EV race. LMR's journey from concept to reality wasn't easy. Early manganese-rich cathodes suffered from voltage fade and poor cycle life, making them unfit for EVs. GM scientists cracked the code with advanced dopants and coatings, stabilizing the chemistry and extending lifespan. By 2024, GM had built over 300 prototype LMR cells, simulating 1.4 million miles of driving. The results? Stable, durable, and ready for mass production. Independent research also showed manganese cathodes could be made with much larger particles, simplifying manufacturing. With these breakthroughs, GM and Ford are moving LMR from lab to factory floor. LMR is about more than better batteries. It's about reclaiming American leadership in a critical industry. For years, battery innovation and manufacturing shifted to Asia, especially China. LMR, developed in U.S. labs, gives American automakers a homegrown advantage. GM and Ford can control the tech, capture more value, and build a North American manufacturing ecosystem. Manganese is globally abundant, with significant deposits in North America, enabling a secure, ethical supply chain. This strategic shift could reduce trade deficits, boost national security, and create high-tech jobs. America can move from consumer to global leader in battery tech. LMR is a blueprint for a revitalized, resilient U.S. auto sector. The U.S. market is dominated by trucks and SUVs, icons and profit engines for Detroit. Electrifying these vehicles has been tough due to their size and battery costs. LMR's high energy density and low cost unlock the mass-market electric truck and SUV. GM and Ford can now offer 400-plus mile range trucks at lower prices, making EVs practical for families and businesses. Simpler, lighter LMR packs free up space for more interior room and innovative storage. Lighter batteries improve efficiency and handling, delivering the rugged utility buyers expect. Detroit's experience with trucks gives them an edge over Tesla's Cybertruck in the heartland. LMR lets GM and Ford offer better, more affordable versions of the vehicles Americans already love. The EV race is entering a decisive new chapter. With LMR, GM and Ford are no longer following, they're ready to lead. LMR democratizes range, making long-range EVs affordable and practical for millions. This is transformative for the American market, especially for trucks and SUVs. LMR also helps unwind risky foreign supply chains, building a resilient U.S. manufacturing base. America reclaims its role as an automotive innovator. As LMR-powered vehicles hit the roads in 2028, the Detroit-Tesla rivalry is more compelling than ever. The game has changed. A new American EV landscape is dawning, promising affordable, long-range, American-made electric vehicles for all.